All right, welcome back, class. This is 9.3a logarithmic functions, and it's related to the exponential growth functions that we were looking at because they're actually inverses. And once we get into some more of the graphing, we'll be able to see that represented on the graph that it is an inverse. When we start here, if we look, 2 squared equals 4. I hope that's pretty clear. 2 times 2 equals 4. 2 cubed is an 8 because it's 2 times 2 times 2. Then 2 to what power is 6? So 2 to the x is 6. Now, we know that 6 is between 4 and 8, so x must be between 2 and 3. How can we find that? Well, with today's lesson, we'll be able to use logarithms, and by that we will be able to find out what then 2 to the power of x is to equal 6. Logarithms, how many of one number do we multiply to get another number? So how should we solve 2 to the power of x equals 8? These are the same statement. 2 to the power of x equals 8 is the same thing as x equals log base 2 of 8. That's how we read that. Log base 2 of 8 is x. These are equivalent. And we know that in this case, x would be 3 because we did it up there. So in this case, it'd be 2 to the power of x equals 8. And a nice way that we'll do that is using these arrows. 2 to the power of x equals 8. I'm a little laggy right now. I think I'm going to close the app and then reopen it here. Let's do that. So again, those are equivalent, and we read that as log base 2 of 8 is x. Hopefully it loads. Okay. So definition, logarithm with base b. Log base b of y equals x is the same thing as this. And we looked at that with an example. So it'd be b to the x. So b to the x, I'm going to rewrite it down here, equals y. And the arrows will kind of help us work through that. Given that b is greater than 0, y is greater than 0, and b does not equal 0. So those are the requirements. And so based on that, let's look at some examples. So we're going to rewrite this first one. Log base 2 of 32 equals 5. So again, we're going to use arrows to help. That's 2 to the power of 5 equals 32. And is that true? It is. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2, which is 32. So let's check this one. 10 to the power of 0. Okay, and 10 to the power of 0 we know is 1. And so that's a true statement. If we see 0 out front, that means it's going to be whatever this base is to the power of 0. It'll always be 1. It has to be, because anything to the power of 0 besides 0 to the power of 0 is going to be 1. Let's check this one. Log base 9 of 9 is 1. So that's 9 to the power of 1 equals 9. So now, in this case, if we have a base, b to the power of 1, it's always going to be that base now for what it equals, because anything to the power of 1 is itself. Let's check this one here. So it's going to be 1/5 to the power of -2, because we go this way, equals 25. So in this case, since we have a fraction and it equals a nice whole number, we're going to want to take the reciprocal. Also notice that we have a negative exponent. So that also is an indicator that we'll need to take the reciprocal. So that becomes 5 to the power of 2. We've practiced this a couple times over the last couple units. Equals 25. And is that true? 5 squared is 25. Yes, that is true. So I hope with practice, and I know this will be the case, with practice, you'll feel more and more confident in your ability to work with that. Okay, right, the exponential equation in logarithmic form. So now we're going to go backwards. We're going to rewrite it the other way. So using the equation up here, it says b to the power of x equals y is the same as log base b of y equals x. So let's highlight and associate b to the power of x equals y. So that would be log base 4 of, well, we have y, so that's what it was equal to, 16 equals, and we said the exponent, oh, I didn't highlight that, we want to highlight this, equals x, that's our exponent, 2, and then we can check it. Let's now work the way we've been used to. So 4 to the power of 2 equals 16. Yep, these look the same, and that's a true statement. So that looks good. Let's try this one now. So again, our base goes down below. B is our base. This is a base of 2, and it equals 8. So that's going to go up here. Log base 2 of 8 is 3, whatever x is. So let's check it. 2 to the power of 3 equals 8. Yes, that's also good. So I hope, again, with more and more practice, it gets more comfortable. Base, our base is 2. So let's log base 2 of whatever it equals, 1/8, equals negative 3, because that's our x or our exponent. And then let's just one more time confirm 2 to the power of negative 3 equals 1/8. So it's a negative exponent, so we would need to rewrite it. Well, actually, we're just trying to show that it's the same here, and it is, so that looks good. So that's how we'll rewrite those. All right, let's evaluate these. So it's log base 3 of 81, and we're evaluating, so we're going to set it equal to our unknown x. This will now become more clear. We're going to go through the same steps. So 3 to the power of x equals 81. We can do this mentally. I hope. If not, we're going to practice it right now. 3 to what power is 81? Well, we can factorize, put a factor tree of 81. That's 9 times 9, which is 3 times 3 times 3 times 3. So that's 3 to the 4th. It takes 4 factors of 3. Therefore, x equals 4. So we evaluated it. We found that x equals 4. And when we substitute that in, 3 to the power of 4 is 81. Yep. Let's do it here. Equals x. So we have 1/4 to the x power equals what? 256. Okay, so let's think. It's in a fraction right now. Our base is a fraction. So if we take the reciprocal, we'll have now a negative exponent, and this will be a nice whole number of 4. So let's do that. I took the reciprocal, so now it's 4 over 1. Now it's a negative x equals 256. Now let's see if we can figure out what x is then. So over here we're going to say x equals, it's going to be a negative number. And let's see, 4 squared would be 16. 16 times 4 is 64. 64 times 4 is 256. So it would have to be negative 4. So if we plugged in a negative 4 for x up here, it'd be 1/4 to the negative 4th. We would take the reciprocal. So now it'd be 4 to a positive x. And that does equal 256. If you have any questions or you're confused, pause it. Try and just work through it with the properties of exponents that you know. So this equals x again. So that's 10 to the power of x equals, what will be this? 0.001. We can go back to how we use scientific notation. That was, oh my goodness, probably 2 units ago. We could just see how many times we're going to move our decimal to the left because it's at 10, which is going to be right here is our decimal. We want to get it back to here. So I'm going to write in green. It'd be like this. This is 10 represented. So it goes back 1, 2, 3, 4 times. If it goes to the left, then x is a negative 4. Also, let's also notice, if it's a negative, it would be the reciprocal. So that'd be 1 over 10 to the 4th. And you could see that it would be a fraction. It's less than 1 here. So I hope some of these things are clear. To the x. 64 to the x equals 2. All right. So we have a bigger number than what we're trying to get to. So another property of exponents, we're going to want to take the root. This x, because this is like, what could be 1 over x, but not yet. So the x root of 64 equals 2. So again, we can prime factorize it, find a factor tree. This is 32 times 2, which is 16 times 2, 8 times 2, 4 times 2. Lots of 2's. It should be 6. 1, 2, 3, 4, 5, 6. It is. And since it's the root, it's going to be x equals 1 over 6. Because we need the 6th root, like this. So then x equals 1/6 here. Because if we plugged 1/6 right up here, then it would be the 6th root. And when we prime factorize it, there are 6 factors, so that would simplify to just 2. Special logarithm values. Let b be a positive real number such that b is not 0. And that's what we said at the beginning. Logarithm of 1. So if we have log base b of 1, it equals 0 because b to the 0th power is 1. Let's do an example. We actually looked at one of these as well. We could do log base 6 of 1 equals 0, or anything for b. That's what it's saying, greater than 0, such that it's not 0 and it's a real number that's positive. So 6 to the 0th equals 1. Yes, anything to the 0th power other than 0 is positive is 1. Right. So we can plug in any b. That's positive. Gosh, I feel like I'm reiterating, but that's important that we understand that. Logarithms of base b. Log base b of b equals 1 because b to the first is b. And again, we looked at one of these too where we can do 6 or anything. I'll do 8. Log base 8 of 8 equals 1. Let's do it. 8 to the first equals 8. Right. That makes sense. Anything to the first power is itself. That's what it's saying in this second special logarithm case. Some more vocabulary. The common log is logarithm with base 10. In your calculator, if you just see, let's see, I believe it'll be log of x. There's an implied base of 10 is what that means. The natural log is logarithm with base e. Oh, look at that. They show it down here. So you see the implied 10 is right there. And then log base e of x is known as the natural log of x. More vocabulary. Can use calculators to use common and natural logs. And we'll see those at the very end of the lesson. Look, right down here. Evaluate. First, let's evaluate these expressions without using a calculator. So we're trying to find out what x is. So we're going to do 4 to the power of x equals 64. I feel like we've actually done this one. But 4 to what power is 64? No, we didn't. It was 256. This case, 4 to the power of 2 is 16. 16 times 4 is 64. Therefore, x equals, I almost wrote 4, 3. Good. 1/4. This one, I know we did. Because look at this. It's a fraction and a big number. So it's going to have to be a negative exponent. 1/4 to the x equals 256. So we would have to have a negative exponent. And 4 to the 4th would be 256. So that's how we would do that one. Okay, now it's a big number, a whole number, and a fraction. So I'm already kind of seeing we're going to need to use the reciprocal. And let's just see that. 2 to the power of x equals 1/8. Well, if we think 2 to what power is 8, that'd be 2 to the 3rd. So if we take a negative exponent, now it's a fraction. So that'd be x equals -3. And I hope you start to recognize some of these things. Equals x. Let's just keep practicing. Okay, we have a bigger number. Both are whole. Whole. Nice. Positive whole numbers. So I'm thinking we're going to need to use a fraction as an exponent because we need to use a root. 32 to the power of x equals 2. I think so. We have to get from 32 down to 2. So we want a root. It's going to be the x root of 32 equals 2. How many times would we need to factor 32? It'd be 5, and we've seen that a couple times. If you don't believe me, make a factor tree, see how many 2's you have to factor it. 1/5 is what this would be, because we would substitute that right here, and then it would be the 5th root, can't grab my cursor, equals 2. And that's what x equals. Now with these last two, we're going to use a calculator. Log base 10, again it's implied, log base 10 equals 7. Since the expressions are in base 10 and natural log, you use your calculators. So let's check. I want this over here. Oop. All right, second, not second, look, we just want log. Log of, it's already implying that it's a base 10. 7 equals, it's a fraction. This is the same fraction I got earlier, so that's good. 0.845. Typically, I'll probably have you round to the nearest hundredth. We'll see. Natural log of 0.25. So, again, we can use a calculator because it's a base 10. That now is right here, natural log. Natural log of 0.25 equals negative. It is negative. Negative 1.39. Again, I'll round to the nearest hundredth. And then let's review. The common log is log base 10 of x equals log of x because that's implied. And then the natural log is log base e of x equals the natural log of x. And then that's when we can use these calculator properties. This stuff is fairly new, some incorporated properties, so I hope you remember your properties of exponents. And again, with practice, so with the homework, it should get better and better. So let me know if you have any questions, and thanks for watching. All right, I'll see you. Bye.